Yes, welcome students. So now today we are going to understand our next program, next part B lab program, that is program number 11, that is write an embedded C program to interface and control a stepper motor. In the previous tutorial you understood how to interface and control a DC motor. So now you're going to understand how to interface and control a stepper motor. So DC motor, two polarities, you're giving positive and negative voltage, and if you interchange the polarities, it used to change the direction of rotation. So now stepper motor, you can precisely control the movement. You can precisely rotate the stepper motor for any degree which you want. That is what is a stepper motor. It will not rotate continuously. Instead, you can rotate it step by step or in the discrete steps. So this is what you're going to learn now. Now, if you already know the concept of of interfacing and controlling the DC motor, this won't be that much difficult to understand. So now stepper motor or DC motor, and again the stepper motors, one stepper motor is something like two DC motors. Now what it does compared to the DC motor, the stepper motor will move in discrete steps. It has multiple coils called as the phases, and by energizing each phase in a sequence, you can move the stepper motor one step at a time, and you can very precisely position or control the speed of the stepper motor. So this is what you're seeing is the stepper motor here, and the internally it is something like this. You have these are the poles which I was mentioning even in my earlier tutorial class when I was explaining the actuators and centers. There when I explained the stepper motor, I was talking on this the poles of the stepper motor: pole A, pole B, pole C, and pole D. And this is what the rotor, this is the stator what you are seeing, and this is what the rotor, the one which rotates, and it has many teeth you can observe here. Now a stepper motor will have 50 teeth in it. Now and this is what I wrote, and this I've already explained you in my earlier classes. The pole A, pole B, pole C, pole D, and each pole has windings. And so if I take two opposite poles, the windings are in opposite directions. And when I energize A and C, if this is acting as north, this will be acting as the south pole. And when I energize B and D, if B acts as the north pole, the opposite one will be acting as the south pole, because the windings are in opposite direction. And what you're seeing is the rotor. I've written 8 teeth here, but you'll find 50 teeth on this. And I also explained you the different configurations of the stepper motor. One is full step configuration, wave step configuration, and half step configuration. Now what kind of a stepper motor we use here is the wave step configuration. That means if you energize one coil at a time, I have shown here. Now if you energize A, and this is for the other one. I've written it for the full step waveform. So I have in the next slide I'll show you. Yeah, this is for the wave step operation. In wave step operation, you can if you energize one coil at a time, the stepper motor will rotate by one step. So you energize coil A, the stepper motor rotates. This acts as the south and it repels, so this gets moves here, this towards this. And next you energize coil B, so like this. And next you energize coil C, next you energize coil D. So this is wave step configured stepper motor. Now in our example, this I've already explained even the previous session or the previous theory classes. Now if I want to make this rotor rotate in the clockwise direction, now I got to energize the coils in this order. First I have to energize coil A, and then coil B, coil C, and then coil D. Now if I energize in the reverse order, first D, C, B, A, the rotor here rotates in the anti-clockwise direction. Now in the example which I'm in the program which I'll be explaining now. Now this is how we have considered. So these poles in my program, so the pole A of the stepper motor is connected to port pin 0.12 and B is connected to 0.13. Now why they need to be connected to these port pins only? No, you can connect them to any port pins, but this is what I'm assuming. Right now I'm taking pole A, I'm just connecting in my program, I'm connecting it to P0.12 and pole B to 0.13, port pin 0.13, and pole C to 0.14. These are the port pins which I'm using in my program, and the schematic, the connection also, the stepper motor to my controller, these are the port pins which I'll be doing. The pole A of the stepper motor, I'll be connecting it to port pin 12, and pole B of the stepper motor, I'll be connecting it to port pin 13. Similarly, pole C of the stepper motor, I'll be connecting it to port pin 14, and similarly D, I'll be connecting it to port pin 15. Now this is how I energize. Pole A, how do I energize? This is what the data I have to give. So port pin 12, P0.12, I have to make it as 1, and the remaining port pin should be made as 00. That means now I have only pole A energized, pole B is not energized. This is connected to pole B, not energized. Pole C, this is the port pin which is not energized, like this. Now pole A energized. Next time I go for energizing the pole B. Next I go for energizing pole C. Next I go for energizing the pole D. Every time you energize a pole, the stepper motor rotates by one step. That means it's going to cover 1.8 degree. Now when you energize, 1.8 degree, here 1.8 degree, 1.8 degree, 1.8 degree, total 7.2 degree. When I energize in this sequence A, B, C, D, the stepper motor will rotate by 7.2 degree. And if I repeat the process of energizing A, B, C, D for 50 times, 50 into 7.2 will give you 360 degree. The stepper motor will rotate in one full rotation, or it will cover 360 degree. So that I'll show you in my program when I go. Yeah, this is the program. Now stepper motor embedded C program. As I told in my previous example, this is what the header file required. So LPC21 xx.h, because the same header file applies for LPC21 series microcontroller. And again in my program, as it was in the previous session, there I add clockwise user-defined function and anti-clockwise. Here also I have prototype two user-defined function, one with the name clockwise, another with the name anti-clockwise, and these are the two prototypes. And clockwise again not returning anything and not taking any parameter. Anti-clockwise also not returning anything, not taking any parameter. Along with that, I have these global variables var1 and var2. Long integer var1 and var2, and I have I, j and k initialized to 0, again global variables. So I'm using these things for the looping purpose. Now inside my program, as I already mentioned, now I'm connecting pole A of stepper motor to P0.12, and pole B to 0.13, C to 0.14, and D to 0.15. Now accordingly, since all my port pins to which the poles are connected are in the range 0.0, P0.0 to 0.15, now I have to make use of pin cell 0, because I have to make 0.1 to 0.15 all of them to operate in the general purpose IO mode. Now it's not necessary to make all of them to operate in the general purpose IO mode. If I make only P0.12 to 0.15 to operate in the general purpose IO mode, it is enough. Now but what I'm doing is I'm using this by assigning the 000 to pin cell 0. I'm making all the port pins, that is P0.1 to P0.15, to operate in the general purpose input output mode. mode. Now I have given P0.12 and P0.15 also operating in the general purpose input output mode, but the other pin P0.02, P0.11 current 11 is not important for me, but I'll be focusing on only this port pins. Next, after making P0.12 to 0.15 operate in the general purpose input output mode, next I got to make these port pins P0.12 to 0.15 operate as output port, because again I'm sending the data from controller to the device, external device. What is the device? Stepper motor. Now what is the data? Now, which is the register we'll use in order to make P0.12 to 0.15 act as output port? I have to use IO0 DIR, because these are the port pins of the port 0. IO0 DIR. And what is the data? This is what the data. Now I have written here in binary. So these four zeros corresponds to this first 0, these 4 zeros corresponds to the next 0, and these 4 zeros corresponds to this 0, and these 4 ones corresponds to this F. And to the left side you have zeros for these zeros. Let us not worry about that. Now why I have taken F000 itself? Because in order to make P0.12 to P0.15 act as output. Now in this data will do that. How? You can count. This is P0.0, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, this is 0.8, 0.9, 0.10, 0.11, and this is 0.12. Port pin 0.12, and this is port pin 0.13. This is port pin 0.14, and this is port pin 0.15. Now these are my port pins from 0.12 to 0.15. These are the one which I need to make them as output. Now hence I am assigning 111 to this port bit, the 12th bit and 13th bit, 14th bit and 15th bit of IO0 DIR are made as 111, and this what it will do, it will make the corresponding port pin P0.12 to P0.15 act as output pins. So that is what we made here. And next, again, as usual, as you understood in the previous interfacing and controlling the DC motor, so again there was a while loop, infinite while loop. Here also I have an infinite while loop. So while 1 is an infinite while loop. Now I am running a for loop for I j is equal to 0, j less than 50, j plus plus. Now 50 times in clockwise rotation, 360 degree. Now I told when a stepper motor in the wave step rotates one single step, it covers 1.8 degree. Now and the formula was also there. The formula is this. I'll write and show you the formula. Let me write here. Step angle is equal to 360 degree divided by 4 into 50. This is the step angle for 360 divided by 4 into 50. What is this 4? Number of poles, and what is this 50? Number of teeths. And the stepper motor has 50 teeths, and the stator has 4 poles. So when I do this, now I get is equal to 1.8 degree. That means when a stepper motor moves by one step, it covers 1.8 degree. 1.8 degree. This is what the step angle. Now if I want to make the stepper motor one step, it makes 1.8 degree, that you understood. Now to make the stepper motor rotate complete 360 degree, I want to call this function how many times? 50 times. Now how calling this function clockwise 50 times will make the stepper motor rotate 360 degree, that I'll show you in a short while. Now so this you understood. Now say this for loop is without the semicolon. That means this clockwise will be called how many times? 50 times it will be called. So 0 to 49, that is 50 times this clockwise will be called. Let me go to the clockwise function now. Now this is what the clockwise is. Here you can observe. Now inside the clockwise, now var 1 is equal to, this is what I am assigning, 800. Now when I write the same thing in binary, now here, so these zeros corresponds to this, these zeros corresponds to the next 0, and this is what is 8. 100 in binary is nothing but what? 8, and I have written for this 0 also 000. Now when I take, this is the value I'm assigning. If I consider the bits, this is the bit which corresponds to 12th bit. Now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the 12th bit, which corresponds to P0.12, and this is the 15th bit which corresponds to 0.15. Now right now I've taken this data 8 and 1 is here. Now that is what is assigned to var. And next, for I is equal to 0, I less than or equal to 3, 0 to 3, that is 0, 1, 2, 3, 4 times. Now this loop will repeat. Now why 4 times only? Because A, B, C, D. Now I have 4 poles. I got to repeat this for all the 4 poles. Now var 1 is equal to var 1 left shifted by 1 bit. Here this 1 was here initially. Now I need to energize the pole A. To energize the pole A, this is in this sequence, you can observe. Pole A, this is B, this is C, and this is D. Just look here. To energize the pole A, so this corresponding P0.12 should be made as I. To make that high, this one should be here. I have to take 1 here, but I have 1 here. Now what I'm doing, left shift. When I do left shift, this 1 comes here. That means pole A is energized. This is the case what you are seeing. I gave 1 to P0.12. That means pole A will be energized. Now this left shifting I'm doing. When I do left shift, this 1 comes here. And 1 0 is added to the left. Yeah, and that is assigned to var 1. So new var 1 value will become this, left shifted by 1 bit. And now IO0 pin is equal to var. Now IO0 pin is equal to var. The data is now instead of 8, it is 0 0 0 0, and this is 1 0 0 0. That is what the value of var when I do this. Okay. Now, and the same thing is being assigned to IO0 pin. Now this I didn't tell you. Now earlier in the previous example we were assigning it to IO0 set. Now that is not necessary. Now you can directly assign it to the port pin. Now when I assign this, so this value at this, this will make this bit is connected to what, P0.12, and A is energized directly. Now and A is energized, and I want to observe the step movement, right? Now this is the delay again. This is with the semicolon, you can observe here. Now after energizing A, the stepper motor will rotate by 1 step, and just to observe that, I am just giving this delay. Now for every step the stepper motor stops and again goes back. So I is incremented, I is 1. So next time what you do, again you take the var 1 value. So now 1 is here, left shift it by 1 more. Now this 1, it will come to this position, and what is energized? B is energized. It is this case. So pole B is energized. Pole B gets energized. When in the second iteration, 1 will be here. 1 comes to this position. And then go to that. Pole B is energized. Now the stepper motor will rotate in clockwise direction for 1 more step, 1.8 degree. Next. Now with a small delay, again go back. I becomes 2. And again less than or equal to 3. Now again 1 more time left shift. So this 1 which was here, will come to this position. So this 1, comes to this position, and C gets energized. It is this case. So this case P0.14 gets energized. The pole C is energized. Next, the stepper motor rotates by 1 more step, 1.8 degree. So delay, goes back again. I is 3, less than or equal to 3 condition is true, comes here again. Now left shifted by 1 more. 1 was here earlier, now the 1 gets shifted here, and D is energized, rotates for 1 more time, 1.8 degree. Now totally 4 times it is rotating the stepper motor, 4 steps it is rotating this loop. Now 4 into 1.8 degree, that is 7.2 degree. So the one time this clockwise is called, one time this clockwise is called, this function is called, the stepper motor rotates 4 steps. In that 4 steps it is covering 7.2 degree. Like this clockwise function is called how many times? 50 times. 50 times you are calling. 50 into 7.2 is 360 degree. Now when this function is called for one time, the stepper motor will rotate 7.2 degree, and like this you are calling this anti-clockwise function for 50 times, and it will return 50 into 7.2, that is equal to 360 degree. Now once it is called for so many times, 50 times, the stepper motor will rotate in clockwise direction for 360 degree and it will come out. And now this is the delay. Now, and once the stepper motor rotate 360 degree clockwise direction, I want the motor to stop for some time and then start rotating in the anti-clockwise. This is the delay for stopping the motor after it rotates 360 degree clockwise. Now, and again same as usual, j is equal to 0, 50, j plus plus, because I want the stepper motor to rotate in anti-clockwise direction for 360 degree. So again 50 is the count. Now anti-clockwise function I'm calling. How many times I'm calling? 50 times. Every time this anti-clockwise is called, how many steps the stepper motor will rotate? 4 steps it will rotate. And every time it rotates it rotates one step, 1.8 degrees the angle covered, 1.8 into 4, 7.2 degree. And this function itself is called 50 times. 7.2 into 50, that is 360 degree in the anti-clockwise direction. Let me go to the anti-clockwise now. This is, and anti-clockwise, this is the value which I'm assigning to var. Now under the binary I have written here. Now this 0, these 4 zeros corresponds to this, and next 4 zeros, these 4 zeros corresponds to the second 0, these 4 zeros corresponds to the third 0, and these 4 zeros corresponds to the fourth 0 here, and I have 1 here. This 1 actually comes here to the position 16th bit, and this is the actual position of 0.12 to 0.15. You can count from here: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have taken 1 to this position. Now when I enter into this loop, as usual, I is equal to 0, I less than or equal to 3, I plus plus. Now what I do here? Right shift I do. Here I was doing left shift because 1 was here. Now I was taking 1 here, next to this position, next to this position, next to this position. Here I do the right shift because I have 1 here. Now when I do 1 bit right shift, this 1 goes here, this 1 goes here to P 0.15th position. Now which one is energized? P 0.15 is energized, and this is connected to what pole? This is connected to pole D. Is it? 0.15 is connected to pole D, and the pole D is energized. What is that you are energizing first? Pole D. And next you energize pole C, next you energize pole B, next you energize pole A in the reverse order, and the stepper motor will rotate in anti-clockwise direction. And every time you shift right it by 1 bit, assign same thing to IO0 pin. IO0 pin. Now the stepper motor will rotate in anti-clockwise direction by 1 step. Now go and with a delay. So after some delay, go back, repeat this for loop for 3 more times. In the second iteration, this one which is here, it goes to this position, which gets energized. P 0.14 will get. I have not written here. P 0.14 get energized. Next, in the next third iteration, P 0.13 gets energized. In the fourth iteration, P 0.12 gets energized. That nothing but pole A gets energized. Now you have the stepper motor rotating in anti-clockwise direction for 4 steps and covering 7.2 degree, and you have this anti-clockwise called how many times? 50 times. Now 7.2 into 50, 360 degree in the opposite direction or anti-clockwise direction. And again a delay, since this we have written inside the while loop. So after rotating the stepper motor in anti-clockwise direction for 360 degree, the stepper motor stops after 1 full rotation, and then again goes back to the while loop, and again it will rotate in clockwise direction for 360 degree with some delay, anti-clockwise 360 degree, and this keeps on repeating. So this is what the program is. So now we'll go for executing this in the Keel IDE, and then we'll also see the execution of this using the protest simulator. Now this is the Keel. I have already kept it open. Now let me open the new project. Let me save it on the desktop by creating a new folder. Let me name it as step underscore motor. I'll open this folder. Inside this I'll save it step underscore m. Okay, stepper MOTOR, stepper motor. Save. The project is saved. I have to choose the controller. LPC 2148 is my controller. say OK. Now it says startup.sh. Since you're writing an embedded C program, startup.sh is required. Say yes. Now target is created and to the source script startup.sh is added. Now I need to add my C program. Let me write my C program. I'll copy from the PPT. Because I've explained this program, so let me use this program itself. Paste. Let me copy the functions. Copy. Paste. Okay, I'll save this. Again, step motor. Okay, let me save this as step underscore mo. Let me give motor dot c. It's a C program. Now the program is saved. Now this program has to be added to the source group. Right click here, step motor dot c file, add it, close. Now it is added. Now what you have to do, as I already told in the previous example, go to the startup.s configuration wizard and check PLL setup because the clock frequency required is only 12 megahertz. Now if this is also checked, it will multiply it by 4. I don't want to multiply it by 4, so PLL setup is unchecked. Now after doing this, I'll just save and I'll close the startup.s. Now and then we got to do few changes here. Go to the right click on the target, go for options for the target one. Target as you have to make sure whether it is 12 megahertz and check microlib, and then go to output, check X file because X file is required for burning it into the microcontroller, and linker, use memory layout from target dialog. Okay, this is what you have to do. And now it's ready for compiling. Let me compile. The program got compiled, 0 errors and 0 warnings. Now let me build it. So build successfully, and the X file is also created. Now I'll debug here first and show you, and later we will go for simulating the same in the protests. Okay. So I'll just minimize this window because that is not required for us. Now go to peripherals. So GPIO slow interface port 0, because again we are using port 0. Go to this. This is what you get. Now let me debug the program and show you. Now observe now. Now I'm making all the port pins as operate in GPIO mode by assigning 0000 to pin cell 0. F11, all of them are operating in general purpose input output mode. Now IO0 DIR. Okay, this is what I'm assigning F. Now what will happen now? P0.12, so P0.12 to P0.15 they will be made as I in IO0 DIR. P0. Here this is 8, 9, 10, 11, 12. This is 12, 13, 14, 15. All this will go high now. See? Now this is executed, the statement is executed, and all of them are high. Now what this is doing, it's making the port pins as output. These bits, these port pins are made as output pins. Next we go to the while loop, infinite while loop and for loop. Now make a call to the clockwise. This clockwise function will be called how many times? 50 times. Now in the clockwise, I'll just do it for one or two iteration, and then I'll just run it and you can observe the output here. Now what I'm doing is, this is the data which I'm assigning to var. Now var 1, okay, this is the data. Okay, now 8, so that means I have 1 year where at this position. Next, by shifting it left, I'll take it to this position. Okay, now for loop, for I is equal to 0, I less than or equal to 3, I plus plus, let me drag it little down, I plus plus, first iteration. Now I'm shifting it left, where by 1 bit. Now I'm assigning the same to IO0 pin. Observe now the where 1 where it will come, the 1 will be here, 1 will be here. See here, this is 1. Now since it, and the corresponding bit is also 1, that means the port pin 0.12 is high and pole A is energized, and with after some delay again we go back. So which gets energized, this gets this gets the bit gets shifted here. Observe here, bit got shifted here, and IO0 pin also you can observe. I'm not using IO0 set, I'm directly using IO0 pin. It got shifted here. Now you have P0.13 get energized, that is pole B is energized. Next what will happen? So pole C is energized. Next pole D is energized, that the P0.15 is energized. This is how it goes. Now let me run it at once and show you. So run, I can observe now. Now it's still running in the clockwise direction. Anti-clockwise it will move in this direction. See this tick marks, this is sticking, this is sticking, this is sticking. In this direction it is moving. Now for anti-clockwise it will move in the reverse direction. I'll show you when it changes. $50 times it will happen like this. Yeah, now you observe the direction is changed. Now this tick it's going, and after this it will jump again here. Now the stepper motor is running in the anti-clockwise direction. Now these are the port pins which are connected. This is connected, this port pin P0.12 is connected to pole A of stepper motor. This is connected to pole B of stepper motor. This is connected to pole C of stepper motor, and this is connected to pole D of stepper motor. Let me stop debugging here, and now we will go to the protest simulator. Okay, I'll minimize this. This also I'll minimize. I have already created stepper motor. The basic connections I have already made. So I'm opening the protest simulator now. Yeah, this is the and this basic connection, which this remains same. Even LED program, when you understood sample program, this was same. DC motor also this was same, and now this is what I have to do now. Now let me zoom it to the required level, because my port pins are now P0.12, 13, 14 and 15. These are my port pins. I think this should be okay. Now I need the stepper. Before the stepper motor I need the driver. Again the same driver I'll use, that is L293D. So let me place it conveniently. I'll place it here. Okay, yeah, this is fine. Yeah, okay. Now let me do this connection first. Now I need to give the voltage supply to this. Let me move little up. Yeah, this is fine. Now I have to give 12 volt to this. Now I take a shell, place the shell here. I'll rotate it. Rotate one more time. Yeah, I'll connect it to this, and ground is also required. Let me take the ground. This is the ground. Connect the other end to the ground. Other end to the ground, and this I have to make it as 12 volt now. Okay, now I'll just copy this, copy to clipboard, paste from clipboard. Yeah, little this side I'll move because they are merged. Okay, now this I'll connect it to pin 16. This is plus 5 volt, and the other terminal is connected to ground again. Now this is not 12 volt, I have to make it as 5 volt. Okay, and these are the grounds, and they are connected to the ground. Connected to the ground. Now this 12, these are my port pins now, P0.12, P0.13, P0.14, P0.15. so this I'll connect it to 2. Yeah, before that let me explain. Yeah, see, I have 4 inputs here, in 1, in 2, in 3, in 4. So this is where I'll connect pole A. Okay, so P0.12, sorry, this is P0.11, P0.12 here to this, P0.13 to this, and then P0.14 to 10, P0.15 to 15. This is what I've done. Now I need to place the stepper motor. Now stepper motor is here. I've already motor stepper. I'll take this. Let me place here. The DC motor was having only 2 terminals, and this has 6 terminals. Now this is pole A. Look here. This is pole A. This is pole B. This is pole C. This is pole D. Okay, and these 2 are for supply. Now DC motor external power supply was not necessary, but for stepper motor you have to give the external power supply, AC supply, 12 volt AC you have to give. Now that also I'll connect. First let me connect the power. Yeah, here. Yeah, so this is one. If I go here and it is DC, I can change it from AC to DC or DC to AC. Let me place here. Okay, I'll connect which pins we have to connect. The middle pins we need to connect. Okay, now from here I'll connect it to this. Now I'll just AC, yeah, it's AC. So if you click this dotted line, it is AC. If you click this solid line, it becomes DC. Now, yeah, how much volt? 12 volts I have to give. That I have to change. If you double click there, it will come. Just double click here. So, and it was 0. Now made it as 12 volt. Okay. Now, so I have to connect this. This is P012 current. I have to connect it to the pole A. Now 2 equivalent is out 1. From here I need to connect it to this. This is pole A and this is pole B. That 6 should go to pole B. And connect like this. Okay, or let me come from this side. Yeah. Next 11 is connected to pole, yeah, C. Here, and 14 is connected to pole D. So this is what you have to do. All connections are made now. Now let me save this. Now only thing that we need to do now is I have to dump my program to this. Now let me go back here. Let me compile again, build again. Yeah, X file is created. Now I go here, I'll double click on this. I have to choose my X file, open. So my program is on the desktop. Step motor is the folder. Step motor. This is my X file. Open. Okay. Now my X file is loaded. My program is loaded into the controller. Now I can go for simulating. Now when I say run, observe now, rotating in the clockwise direction. Oh, sorry, a step angle I have to change. I forgot to do that. So step angle by default it is set to 90 degree. Don't set it because 50 steps I have given, correct, no? As per the program you have to set. But when you execute in the lab, correct, no? The stepper motor step angle is fixed there. The physical stepper motor step angle is fixed, that is 1.8. Since this is simulation, you can change it to anything. Now 1.8 degree. Now let me run simulate. Observe now, the motor is rotating in the clockwise direction. How much it will rotate? One complete 360 degree in clockwise direction. After that it will stop and it will rotate 360 degree in anti-clockwise direction. Here you can observe the shifting of data also. It is A, B, C, D. Observe here A, B, C, D. Observe that red light, red color. I'll show you again. A, B, C, D. It is in this order. It is energizing the poles, and the motor is rotating in the clockwise. Now the motor has completed 180 degree clockwise, and it is going for the another 180 degree. Every step you can see, the observe steps wise it is moving. Every step it is covering 1.8 degree. Observe now. Now it's almost completing 360 degree. Yeah, it's stopped now and coming in the reverse direction, anti-clockwise direction for 360 degree. Anti-clockwise. Now you observe this. Now it is shifting from DCBA. DCBA. D. Observe here. DCBA. And when it goes here, from here again it will jump back to this. It will not come like this. It will jump back to this. Observe, it is running in the anti-clockwise direction. So 180 degree in anti-clockwise is finished. Now another 180 degree. You can observe the counts also here. Counts also here. So another 90 degree to complete. And after it finishes anti-clockwise rotation for 360 degree, it will go for again 360 degree clockwise and anti-clockwise. Just keeps on repeating. Completed anti-clockwise. Now again it is going for the clockwise, and since we have written it inside the while loop, this goes forever. Let me stop. Now I don't want the stepper motor to rotate 360 degree clockwise and 360 degree anti-clockwise. I want the stepper motor to rotate 180 degree clockwise and 180 degree anti-clockwise. What is that I have to do? Now only thing that I need to do is, I was calling this clockwise for 50 times. 50 into 7.2 was 360 degree. Now I have to call it half of it for 25, and this also 25. Now if I make this as 25, it will do clockwise 180 degree, anti-clockwise 360 degree it will do. Now let me do both 180 degree itself. So I've done the changes. I have to save my program, compile again, build again. I got a new X file. Let me burn my new X file to the controller. Yeah, this is the one. Open. Okay. Now run the simulation. Observe now. Now it will go 180 degree clockwise. See, 180 degree clockwise it is coming. So if you want, let me zoom it a little more. Yeah, 180 degree clockwise. See the yellow pointer you observe. Observe the yellow pointer here. Now 180 degree. After completing 180 degree, it will go anti-clockwise again. Stopped. 180 degree completed. Now 180 degree anti-clockwise again. So that is what is the stepper motor. You can control it. Now I want to rotate 90 degree. I want to rotate 60 degree. I want to rotate 180. So all that you can do it. Now almost completing 180 degree in anti-clockwise. Stops. Now again 180 degree in clockwise, and this repeats. So this is the changes what I made. So 25 25 reduced. Okay, this is what the stepper motor example is. I hope you people, those who watch this video, will definitely understand the stepper motor program. Now will end for today, and next class will continue with the next session. So I'm planning to complete in the next session. I'm planning to complete the module 3. After completing module 3, will come back and cover some more lab programs from part B, 1 or 2 lab program part B, and then we will start the module 4. Thank you.